Einstein once said, "In the middle of every difficulty, there lies an opportunity." What was the difficulty that we faced in the previous session? We connected the LEDs to the digital pins of the Arduino. In total, there are 14 digital pins, and to connect one LED, 2 digital pins are essential. So by using all the digital pins of the Arduino, we can connect only 7 LEDs. What do we do now? Even Sinbad the sailor only went for 7 voyages. Are you ready to start the 8th voyage with me? Let me get you the paddles to travel. First, search Arduino on the component library. Then, drag the Arduino board from the component library to the workspace. Let's connect more LEDs to the Arduino with the help of a component familiar to you. You have already used it earlier to design circuits. Yes, it's the breadboard. Using a breadboard, we can connect more LEDs to the Arduino. Let's search for a breadboard in the component library. You can see there is a small and big breadboard. Here, we can select a small breadboard, then drag and drop it to our workspace. Small breadboard is just similar to a big breadboard. A single horizontal line of a breadboard has the same connection, and a single vertical line in a breadboard provides the same connection. I hope you remember the connections of a breadboard. Let's now explore how to connect LEDs more than 7 in number to the digital pin of an Arduino with the help of a breadboard. Have you heard of common ground concept? We can connect the negative terminals of all the LEDs to one common point using the breadboard, so that every LED will get the negative supply needed for its cathode, so that we only have to make connections for the anode of the LEDs using the digital pins. To make any concepts clear, let's try it out. First, let's try to connect a single LED to the Arduino using a breadboard. Select an LED from the component library. Drag and drop it to the workspace. Now, click on the LED. Change its color to green and place it on the breadboard. Change the wire color to black. And let's make a connection from the ground pin of the Arduino to the negative rails of the breadboard. Now let's connect the cathode of the LED to the negative rails of the breadboard, where the ground pin of the Arduino is already connected. Then change the wire color to red and make a connection from the digital pin D2 to the anode of the LED. Now click on Start Simulation. Well, the LED is off, so click on Stop Simulation. Well, the LED will not glow unless we do the coding to set the digital pin D2 to high. So let's do coding to turn these LEDs on. Click on Code. Drag these code blocks to the left to remove them. Then go to the Output block section. Here we are using only one digital pin, so we require only one set pin block. Drag and drop the set pin block and change the pin number to 2. Here, anode of the LED is connected to pin 2, so we keep the set pin block to high. You can always click on Code to hide the coding space such that we can see our workspace completely. Now click on Start Simulation and the LED glows. Now we can learn to connect more LEDs to the Arduino using a breadboard. So click on Stop Simulation. Let's add more LEDs to the workspace and connect them to the Arduino. So let's add a second LED. Change its color to green and place it on the breadboard. Now add the third LED to the workspace. Change its color to green and place it on the breadboard. Now let's add the fourth LED. Change its color to green and place it on the breadboard. Similarly, let's add up to 9 LEDs with green color in the breadboard. The 5th, the 6th, the 7th, 8th, and finally the 9th. So we have placed 9 LEDs to the breadboard from the component library. Are you excited to connect all these LEDs to the Arduino? Let's do the connections. Change the wire color to black. And let's connect the cathode of all the 8 LEDs to the row where we have connected the ground pin. Here we have connected cathodes of all LEDs to a common ground point in the Arduino. So this is known as a common ground concept. Now we have to connect the positives of the LEDs to the digital pins. Change the wire color to red. Connect the anode of the second LED to the digital pin 3. Connect the anode of the third LED to the digital pin 4. Connect the anode of the fourth LED to the digital pin 5. Connect the anode of the fifth LED to the digital pin 6. Connect the anode of the sixth LED to the digital pin 7. Connect the anode of the seventh LED to the digital pin 8. Connect the anode of the eighth LED to the digital pin 9. Connect the anode of the ninth LED to the digital pin 10. We have finished the connections. Now let's do the coding. Click on the code block. We have connected 9 LEDs to the digital pins of the Arduino. So we need 9 set pin blocks. Let's drag them one by one. There you go. Let's change the pin number to 2, 3, 4, 5, 6, 7, 8, 9, 10. And then set them to high. Now we have set them to high as the positives of all LEDs are connected to the digital pins. Click on Start Simulation and you can see all LEDs are turned on. We have a number of LEDs connected to the Arduino, right? Aren't you excited to see some beautiful dancing patterns with these LEDs? Let's get it done. We can turn the LEDs on and off in the same way we did in our previous projects. Now the LEDs are on. To create a pattern, we also have to make them on and off in a rhythm. Click on Stop Simulation. Now click on Codes and go to Control. Add a Wait 1 sec block to the previous code block. And now duplicate the entire code block and place it below the Wait 1 sec block. To turn the LEDs off, I'm setting all these pins to low. Click on Start Simulation and you can see that the LEDs are turning on and turning off. Now we have created a simple pattern using 9 LEDs. Click on Stop Simulation. Let's create one more pattern. And for that, click on Code. Duplicate these blocks and place it over here. Let's set pins 3, 5, 7 and 9 to low. So only LED 1, LED 3, LED 5, LED 7 and LED 9 will turn on, and the other LEDs will turn off. Now in this section, set the pins 3, 5, 7 and 9 to high, keeping the remaining pins to low. So only LED 2, LED 4, LED 6 and LED 8 will turn on, and the other LEDs will remain off. Now click on Start Simulation. Yes, we have got another pattern, and it looks fun and interesting. First, all the LED turns on. Then all the LED turns off. Then 5 of our LEDs are turned on, while the remaining LEDs continue to remain off. And finally, the LEDs that were in off condition are turned on, and those 5 LEDs which are already on are turned off. Such a beautiful pattern, right? So now click on Stop Simulation. Just like this, you can create any pattern of your choice with different coding. There he comes. Hey Mr. X. LED's light can produce almost any color in the spectrum. Thank you, Mr. X. Did you hear that? The most common colors that LED comes in are red, green and blue. And by combining the output of these colors in various configurations, almost any color can be created. Coming back to our project. I hope you're clear with all the connections and coding. And also, we have successfully overcame all the limitations. Just like this, we can overcome any barriers and find effective solutions to the restrictions. Now we know about the common ground concept and to connect many LEDs to the Arduino using breadboard. Learning to ride a bicycle is a good thing, but unless you practice it more and more, you cannot become good at it. So try to create different color patterns by changing LED colors and code all by yourself. The next session will be the most exciting one. By recalling everything we have learned so far, let's design a circuit for something very useful for everyone leading a city life. So keep guessing the surprise, and I will meet you in the next session. Until then, bye.